Hello, welcome. My name is Alberto Marquez, and this video will talk about data structures in R. The data types that we have in R, as we have seen, included numeric values, logical values, and characters or strings, text. And these data types can then constitute strings or sets of ordered groups that we call vectors. Defined starting from vectors, then we can create matrices, which are essentially two-dimensional vectors with certain particular properties. And then from matrices, we can create frames, and finally lists. So matrices are essentially two-dimensional vectors. Frames are similar to matrices, but remember, when we manipulate vectors, vectors can only have one type of data in the vector. It was either numerical or logical or something, or text, but we couldn't have more than one type. Matrices are the same, but they are two-dimensional. Data frames are essentially matrices that can contain by column different types of data information. Think about it as a spreadsheet in which one of the columns may contain names or addresses or locations or numerical values by the amount of sales or cost or expenses, anything that is numerical, and all contained in the same structure. So it relates information that could be presented in a numerical way, and when I mean numerical, I mean you can add or subtract, and or other mathematical operations, and non-numerical data. Non-numerical data could include digits, like for instance, in general, a date is a number, but for the most part you don't have numbers. You can make a subtraction to count the different days, but a user ID or a driver's license are also numeric, but they are not. They are numerical digits, but they are not numerical data. And finally, list. If you think about frames to be like worksheets on a spreadsheet file, list would be a collection of these worksheets, just like in a workbook, an Excel, or other package. So it allows you to work with a structure in larger scale, having a collection of different worksheets grouped in the same file. In a similar way, you have list, but the most commonly used structure for purposes of analysis of information in R will be frames. So we're going to, in this video, we're going to work our progress from vectors that we covered before, matrices, from matrices to frames, and if we have time, we'll cover a little bit of list. This may take more than one video, but I hope this gives you a framework on how all these concepts interrelate to each other, because that's going to be critical when you do the assignments and what it's possible to do or not with the different formulas and how to access the data are. So as I mentioned, matrices are two-dimensional data structures. The default is to fill the data by column, and here you can see that if you just type one column 10, it automatically lists the numbers 1 through 10, the integers. So you can use that as a shortcut to fill a vector, just like it's indicated in the screen. And then if you read the vector into a matrix, if there is no other parameter associated to it, it assumes that the matrix will have one column because the vector will be read by column, and nothing has been specified whether if it's going to be more than one column, more than one row, or anything else. So it does it by default to read these in a single column. So let's do this process in the actual software. Alright, so here we are in our studio, and I'm going to list numbers 1 to 10, column 10, and I have the list. So I can assign these into a vector. My vector will contain this data, and I like to have the spacing to make it more readable. So numbers 1 to 10 in the vector, I can list what's in the vector now. It's exactly what we had before, and now we're going to transform this vector into a matrix, and by the command, if I don't do anything else, that has been transformed. Of course, now we should be able to create my matrix, which we're going to assign. There you go. So now we have created a matrix of 1 column and 10 rows. Great. So now we are going to manipulate the information to make a different dimension in the matrix. In this particular case, now we're going to define the matrix to have specifically 2 rows, and by having 2 rows, and if it's filled by column, because we don't change that specification, you will see that the first row reads 1, 3, 5, 7, 9, and the second row reads 2, 4, 6, 8, 10. If we specify that we're going to fill the matrix by row, and that's a parameter in the matrix statement, then that means that the matrix will be filled by row, and in that case the first row will read 1, 2, 3, 4, 5, and the second row will read 6, 7, 8, 9. So let's do just that. Alright, so here we are in our studio, and we can create that matrix vector by typing matrix, not matrix vector, that depends on the vector that we have. Vector, and we say the number of rows. Notice that it's number of rows, but let's specify. And that is to be 2, and the default, you can see right now by row it says false, and the number of row by default is 1, by the number of columns by default is 1. Of course, that depends on the data we have. So by doing this, we generated a matrix that is filled by column. If you look at the column, it reads 1, 2 for the first column, 3, 4 for the second column, 5, 6 for the third column, and so on. We can reverse that or transpose that way of filling the matrix by doing vector, and then we do by row equals true. We can type in the full word true or just T, and number of rows 2 as a parameter, and when we hit enter, now you can see that the matrix has been filled with the information in the vector, but now it did it by row 1, 2, 3, 4, 5 in the first row, 6, 7, 8, 10. Okay, great. Let's go back to the presentation. In matrices, we can enter the data using different vectors, and also we can use something similar to the names that we have used in vectors, but now we have names for the columns and names for the rows, and that facilitates the identification of the data based on these names as opposed to just an index. So that's very convenient when you're manipulating large sets of data. So let's work on this example. in this example, we have the average temperature for a particular region and then the maximum temperature for that same region on a certain amount of months. And then we can create a vector with all this information, and from the vector we can create a matrix. So we first created that the data is separated, we integrate it into a single vector, and from the single vector we transform it into a matrix. And after we do that, we are going to create the vectors that contain the column names and the row names, and then we will assign those vectors to the actual column names and row names of the matrix of temperatures. So let's do that in the software. Alright, so here we are in RStudio, and we say that our vector of average temperatures, which I'm going to denote as AG10, is going to be assigned with the following data. And I made up these numbers. These are not a particular region or anything like that. It's just for purposes of this explanation. And let's say that the average temperature in this region is that, and the maximum temperature in the same period for this location is 55, 58, 1, 2, 3, 5, 58, 60, 7. Alright, on that. So now I can create a single vector with temperature data, the combination of two vectors. So I can list this temp data contains 1, 2, 3, 10 data points. Very good. So now I'm going to create the matrix, and I want the first row to contain the average temperature, the second row to contain the maximum temperature. So I need it to be temp matrix assigned with by filling with temp data by row is going to be equal to true. The data is going to be filled by row, and the number of rows in such a way that if I now list the matrix, I have that. So now the information is listed by matrix. Now let's say that the columns represent the months January through May, and I have a vector called months, which is going to be created with C, and these are labels, so I need February. Of course, you may be reading this information from the data set and from a CSV file. February, March, April, it's 3 letters, April, and there we go. We have the months vector, and then the column names are going to be average and maximum because that's what we have. So say that the type, that type plus that's not so that's right. And we have two data types. One is the average, and the other is the maximum expected. It's the C. There you go. So now I have two vectors. I can now use the names strategy to add the names to the columns and the names to the rows. So the names for the columns is going to be by using col names, and the col names of what? Of temperature matrix. Alright, that is going to be assigned by reading the months. The row names of my temperature matrix going to be read from the vector temperature data type. So in such a way that if I now list the temperature matrix, now I have the data with the corresponding months on top and the nature of the information in the row. Okay, great. So what kind of operations can we perform using matrices? We have the element by element operations just like we had before. We have the plus, minus, times, division, power. We can do the element by element comparison just like we did with vectors, in which we can do larger than, less than, larger equal, less than or equal, an equal comparison or not equal comparison. We can actually do real linear algebra matrix multiplication that will prove useful in some particular settings, but we need to use this convention of the double percentage sign in order for us to do that. And then you have different functions in which, for instance, you can compute the column sum, the row sums of the columns. So let's work these in different examples. All right, so here we are again in our studio, and let's start by creating a couple of vectors. Let's say vector for matrix 1, screen, vector for matrix 1, and we're going to assign the following information. Is going to be 2, 5, 8, 17, and the vector for matrix 2 is going to be the combination of creation of 3, 4. Alright, so here we have two matrices. We can add them together, well, the two vectors as it is, but we can assign them as a matrix. So we can do matrix 1 is going to be matrix of vector for matrix 1, and we say by row equals to true, and number of rows equals 2. Okay, we do that, and then we repeat the operation for the second matrix. Matrix 2 equals matrix using vector for matrix 2 by row equals true, and the number of rows also equals 2. Right? The true has to be capital. Alright. And in a way it's good that you see these errors so you can debug your own. So let's see, we can add we can list these components, matrix 1 and matrix 2, and then we can add matrix 1 plus matrix 2, and it adds cell by cell, and you can verify that. We can multiply in a regular fashion, just entry by entry in each one of the cells. Matrix 1 times matrix 2, and that is not a real multiplication of matrices. It's just one element to the element. Right? We can compare if one is larger than the other, like matrix 1 larger than matrix 2, and we're going to do it element by element, and you see that for the right column it's true, but for the left column it's false. And let's try the multiplication of matrices, see what we can come up with. Matrix 1, and then the double percentage. Matrix 2, maybe this will work, I'm not sure. There you go. Is that the right answer? Let me try. I'm gonna go offline to test it. Well, it looks like I missed something, so let me try it again. Matrix 1, and then I go like this, and then I miss the times in between matrix concept, the percentage, matrix 2, and now that looks better. So very good. That's matrix multiplication, and we did comparisons. What we can still demonstrate is columns. So let's see if we can do call sums for matrix 1. Call sums 1 working. Alright, sometimes we learn by repeating mistakes, right? So let's try it one more time. But this time it's going to be call and then capital sums. And that is actually defined. Then we go matrix. There you go. Now that's the, I have to do capital, sensitive capital. Matrix 2. And I have those values for the column sums. Similarly, I should have row sums. Matrix 1. That means the last. Yes. Yeah. Very good. So we have to be very careful when typing this and be very methodical. Alright, that looks correct. And we have it by row and we have it by column. Great. So we have tested all the operations that are defined for the matrices, and yeah, that's a good feeling. I'll see you in the next video.